Right now, somewhere on Earth, people are arguing over a piece of land, a border on a map, a field a grandfather left behind, a stretch of coast, a river, a name on a signboard. Somebody is in a courtroom about it. Somebody is at a checkpoint about it. Somebody is dying over it today. We have been doing this for as long as we have had maps. And every one of those arguments, every war, every border, every disputed acre in the whole of human history has taken place on a single planet. One out of roughly 200 sextillion. We have never set foot on another one. Not once. In 200,000 years of being human, we have stood on exactly one world and spent most of that time deciding which parts of it belong to whom. Let me show you what else is out there. As of this year, we have confirmed about 6,000 planets outside our solar system. 6,000. Each one found individually, over 30 years, by people whose entire job was to stare at a star and wait for it to get very slightly dimmer. That sounds like a lot, until you put it next to the real number. The best estimate for how many planets exist in the observable universe is about 200 sextillion. A 2, followed by 23 zeros. Your brain is not going to do anything useful with that. Mine didn't either. So here is the version that works. For every single grain of sand on every beach and every desert on Earth, there are about 27,000 planets. We have found 6,000. Total. Ever. Here is the part that catches people out. For almost all of human history, we knew of exactly 8 planets. Ours. That was the list. Not 8 we had studied closely, 8 that we knew existed at all. Every star up there might have had worlds around it, or might have had nothing. We had no idea. We were not being lazy. We simply had no way to check. The first confirmed planets outside our system turned up in 1992, and they were found in the least romantic place available, orbiting a pulsar. The dead, spinning corpse of an exploded star, firing radiation twice a second. 30 years of searching for other worlds, and the first ones we found were in a graveyard. 3 years later came the one that mattered, 51 Pegasi b, orbiting an ordinary sun-like star. Michel Mayor and Didier Queloz won the Nobel Prize for it, 24 years afterwards, which tells you something about the pace of scientific recognition. The entire science of other worlds is younger than most people watching this video. You almost never actually see an exoplanet. They are far too faint, and they sit right next to a star that is billions of times brighter. It is like trying to photograph a moth sitting on a floodlight. So you don't look at the planet. You look at the star, and you wait for it to blink. When a planet crosses in front of its star, it blocks a tiny slice of light. For an Earth-sized planet crossing a sun-sized star, that dip is about 1 part in 10,000. That is genuinely the moth on the floodlight, except you are a mile away, and you are measuring how much darker the floodlight got when the moth went past. Once could be anything. A sunspot, a bad detector, someone's cosmic ray. Twice, at exactly the same interval and exactly the same depth, and you have an orbit. 3 times, and you can publish. That is the transit method, and it found the large majority of the 6,000. There is a second trick. A planet's gravity pulls on its star, so the star wobbles slightly toward us and away from us. The whole star, dragged around by something thousands of times smaller than itself. That wobble shows up in its light. That is how 51 Pegasi b was caught. Now, before 1995, we had exactly 1 solar system to study. So naturally we assumed it was typical. This is roughly like meeting one person and confidently writing a textbook about humanity. We expected other systems to look like ours. Small rocky worlds close in, gas giants parked safely far out, everything in tidy circles. Almost nothing looks like that. The very first planet we found around a normal star was a gas giant bigger than Jupiter, orbiting closer than Mercury, completing a year in 4 days. Nobody had that on their list. There was a genuine period where astronomers assumed the measurement was wrong, because the alternative was that the textbooks were. Then came the super-Earths, rocky worlds several times the size of ours, a category that does not exist in our solar system at all, and which turns out to be one of the most common types in the galaxy. So the most common kind of planet in the Milky Way is a kind we had never seen, because we happen to live somewhere that doesn't have one. And then there are the properly unpleasant ones. Worlds so close to their star that the rock on the daylight side evaporates, drifts around to the night side, cools, and falls as mineral rain. There are planets where it rains rock. NASA now sorts all of this into 5 broad categories. Our solar system fits into 2 of them. So how do you get from 6,000 to 200 sextillion? You stop counting and you start estimating. Carefully. The Milky Way holds somewhere between 100 and 400 billion stars. That is a wide range, and it is wide for an honest reason. Nobody has counted them. That figure comes from weighing the galaxy and measuring its light. The number that actually mattered came from a telescope called Kepler, which spent 4 years doing something extremely boring and extremely clever. It pointed at one patch of sky containing about 150,000 stars, and it watched all of them, continuously, for years, waiting for blinks. That turned anecdotes into statistics. Not, here is a planet, but here is what fraction of stars have them. The answer came back, most of them. Planets are not rare, or special, or lucky. On average, every star has at least one, and plenty have a full set. So our galaxy alone holds well over 100 billion planets. And the Milky Way is one galaxy. In the 1990s, somebody proposed pointing the Hubble Space Telescope at a patch of sky that appeared to contain absolutely nothing, and leaving it there for 10 days. Telescope time is fought over ferociously. This was a proposal to spend 10 days of it photographing the dark. Several astronomers argued it was a waste. It is worth noting that their names are not on the photograph, because it came back full of galaxies, about 3,000 of them. In a piece of sky you could cover with a grain of sand held at arm's length. Not 3,000 stars. 3,000 galaxies. Each one holding hundreds of billions of stars of its own. From that image and the surveys that followed, the count for the observable universe reached roughly 2 trillion galaxies. That was 10 times the previous estimate, and newer work suggests even that is on the low side. 2 trillion galaxies, each with billions of stars. Each star with, on average, at least one planet. Multiply it through and you land somewhere around 200 sextillion planets. That number is useless to a human being. Nobody has intuition for it. So the sand. There are roughly 7.5 quintillion grains of sand on Earth. Every beach, every desert, every riverbed and quarry and sandpit. All of it, everywhere, added together. Divide the planets by the sand, and you get about 27,000. 27,000 worlds for every grain of sand on this entire planet. You have probably heard someone say there are more stars in the universe than grains of sand on Earth. That is true, and it wildly undersells the situation. Planets beat sand by a factor of tens of thousands. And we have found 6,000. If you gathered every exoplanet humanity has ever confirmed and represented each one with a grain of sand, you would not have enough to fill a teaspoon. Which leaves the obvious question. If it is that big, where does it stop? The observable universe is about 93 billion light-years across. That sounds like a boundary. It isn't. There is no wall out there. Nothing changes when you arrive. It is not a place. What limits us is time. The universe is about 14 billion years old, and light from beyond a certain distance simply has not had long enough to reach us yet. The edge of the observable universe is not the edge of the universe. It is the edge of what has had time to arrive. And it moves with you. Stand in a galaxy a billion light years from here, and you would see a sphere exactly the same size around you, full of different things, with the same apparent edge, and the same feeling of being in the middle of it. Everyone is at the center of their own horizon. Nobody is at the center of the universe. 6,000 confirmed. 8,000 more waiting to be checked. Europe's Gaia mission releases a fresh batch this year, and we will pass 10,000 within a few years. And it will still be, mathematically speaking, nothing. 10,000 out of 200 sextillion is not a dent. It is not a rounding error. It is a rounding error on a rounding error. But every one of those numbers is a real place. Real ground. Real weather. There are sunrises happening right now on worlds that nobody will ever stand on, photograph, or name. Most will never be found by anyone, ever, not because we lack the telescopes, but because there is not enough time left in the universe to look at them all. We have been searching for 30 years, and we have counted the first 6,000 grains of sand, 200 sextillion worlds, sunrises on all of them, and every argument our species has ever had, every line we have ever drawn, every border anyone has ever died for, all of it happened here, on the one we are standing on.